Could you spot a quality difference between these two prints? No? This dragon took over 3 hours to print at default, this one just over 1 hour. This Deadpool took almost 13 hours at default, this one just over 5. Today I'll show you how to cut multicolor print times by 60% without sacrificing print quality. Thanks to tool changes like Snapmaker's U1, multicolor and multi-material printing have become faster and way less wasteful. Nevertheless, it's still slower than traditional single-color printing. Tool changing, priming and print settings in general, there is room for improvement. As there's still a speed printing heart beating inside me, I was always convinced when watching the U1, this must be still operating far from its limits. Yes, there are safety margins to make it work for thousands of different users using hundreds of different filament brands. Fair enough, the default has to work properly and it always did well for the U1. Still, I wanted to know where are the real limits and how far can we go without sacrificing print quality. The beautiful thing about the U1, it's built sturdily on the base, but relatively lightweight concerning moving masses due to carbon fiber rods and a well thought out toolhead design. Even more important, it's based on open source Klipper, so there is a lot of freedom concerning tweaking for faster print times. Same for Snapmaker's Orca slicer. We can try almost everything we want to. Today we'll break down and explain some of the most important settings in firmware and slicer to make that machine faster by factors. Always looking at the effects on print time and print quality, with an emphasis on multicolor printing. We'll end up with print times being 2 to 3 times faster than at default. Even though parameter variation like we do today doesn't cost a penny, nothing comes for free. We'll discuss that too. In addition, Snapmaker is generous and there is the chance to win one Snapmaker U1 for one of you. How? You'll need to find the right spot in the video, so watch carefully. Snapmaker is also today's video sponsor and they were a big help to make it even happen. Big thanks for that. Shout out to JNP and his optimized U1 printer config he's providing on his GitHub for PAX firmware, faster tool changes, optimized TMC driver settings and more. A lot of work went into this and to some extent that was part of the inspiration for what I've done in this video today. Down in the description you'll find links to everything shown today for you to try. The principles might work on other printers as well, but as always, at your own risk. Enough, let's push those limits. To do so, we need to access the firmware printer config printer.cfg as the limits for Klipper-based printers are set there. You can access the file system with the Fluid web interface using the printer's IP address in the browser. If in doubt, you can find the IP address in the network settings of your U1. As a safety measure, Snapmaker made those files read only by default. To overcome this, you have to activate Advanced Mode, which can be found under Maintenance in your U1 user interface. I recommend reading that disclaimer as well before accepting. The first important section in the config is the printer section, which defines the upper limits as well as defaults for certain speeds and accelerations. Therefore, the printer won't go over 500 mm per second, even if you set it higher in slicer. For the Z axis, for example, these are defaults for Z movements. Usually, speeds and accelerations for Z aren't controlled by slicer. More on speed and acceleration in general later. JNP, whom I mentioned earlier, bumped that speed limits up to 1000 mm per second and 25k acceleration in his config. Seems quite bold, right? More on that later, but for now these are just limits. Not a problem as long as we don't go there with our slicer settings. What's more interesting for now is enabling for way faster tool changing. We find the corresponding settings in the extruder section for each toolhead. By the way, use Command F to search terms within a file in Fluid. JNP increased these parameters significantly, doubling fast move speed, increasing grab speed, and increasing acceleration for switching by factor 5. Meaning, with these settings, the movement for switching toolheads is faster and those speeds are reached more quickly because of higher accelerations. First, I couldn't believe this would be safe for use or even work at all, but look at the result. I love that. That's bonkers toolhead yielding. So, set up like this, it has a nice impact on print time. That simple 4 cubes at 4 colors saves 6 minutes due to faster tool changes and print time. Therefore, each one of those 225 tool changes is roughly 1.6 seconds faster now. For now, faster tool changing is just one piece of the bigger puzzle, and it absolutely saves time. For this little dragon at 0.2mm standard profile and generic PLA, it saves 12 minutes of print time. Though we can see this only when looking at the actual print time as shown in Fluid. Tool changing speed and acceleration are set in firmware only, so no effect on the slicer prediction. Slicer estimate and print duration, as it's called in Fluid, are quite close for most prints on Snapmaker U1, but we'll watch both closely as the gap gets bigger the faster we go. We'll use that cute dragon as a reference for the improvements of our parameter variation, but we also have a look at more models throughout that journey. So, faster tool changes, 12 minutes faster, again roughly 1.6 seconds per tool change. Every little step contributes, as we'll see. What we'll do next is to use our increased speeds and accelerations for travel moves. This is when the printhead moves without extruding. Therefore, it comes for 3 concerning impacts on print quality. What we must do to even see an effect is to adjust the printer limits in Slicer as well. In the Motion Ability tab, we adjust speeds and accelerations accordingly. We'll quote-unquote unlock here even more later. According to estimate, that's another 5 minutes we save in print time, going at 800mm per second and 25k acceleration. What most of you, me included, do first when starting a print like this, adjusting base settings like infill. By the way, we won't alter layer height as that's part of our reference profile. So 10% lightning infill is more than enough for a figurine like this, as strength and weight is secondary for this creature. This one doesn't need to be filled with grid infill or others. Saves another 12 minutes. We lock that in. A neat little trick that contributes as well, especially for prints like this one, is increasing line width for all features except the outer wall, which is, in this case, mostly defining the outer appearance. Might not be the best idea concerning other geometries, especially for wide and flat top layers, but here it saves 3 minutes. Another little piece for our bigger puzzle. Next we look at the wall generator, which defines how parameters are generated. For this print, Arachne instead of Classic has no impact in quality, but saves another 3 minutes. It adds up, right? Though if we want to go faster, what about print speed? That's an interesting one for this specific use case, as increasing print speeds only doesn't have any impact without touching other parameters. Why is that? Looking at geometry and layers of our dragon model shows, there's hardly any straight line for the toolhead to accelerate to speed. It's mostly about corners. We will talk about those shortly. Therefore, acceleration and cornering speeds are more important than speed settings. Just like driving a car or a motorcycle, you can't go at full speed in narrow corners. And if you want to go fast, you also need to accelerate between corners to reach highest speeds possible. Though excessively high speeds and acceleration can have impacts on print quality depending on the machine and model to print. Therefore, we don't go crazy today for speeds and accelerations. Still, there's noticeable impact on print time, saving another 5 minutes. Next, we have a look at filament settings. As mentioned, we started with the generic PLA preset for this. In general, generic settings are set up very conventionally relative to manufacturers' own filaments. Mostly because these need to work with a wide range of different filaments. Comparing to Snapmaker's own filament, SnapSpeed PLA, we notice a bunch of differences using the built-in comparison function in Orca Slicer. First of all, we look at volumetric flow rate, kind of a natural limiter for print speeds. Simplified, it defines an upper limit of how much filament is allowed to be pushed through the nozzle. Naturally, this also limits speeds while printing, as this is directly correlating. Though adding a higher value only just grants us 1 minute of saved print time. Why is that? Enthusiasts and Klipper pros might already know that. At 0.2mm layer height, at a maximum of 0.5mm line width, and at a max speed of 350mm per second, the maximum demanded flow rate would peak at around 32mm cubed per second. Peak because we don't reach those 350mm per second very often. Though setting higher flow rate limits than generic PLA still help a tiny bit, as there are at least some situations where this print demands higher flows. So we lock that in, the U1 hot end can handle this. Another setting worth mentioning is layer time. I mean, it's a suspicious setting per se, as it carries time in its naming, right? Yes, actually that's another limiter for print speed. For every layer which would be faster than set value, the print speed is slowed down to that set value until desired layer time is achieved. This prevents layers from overheating and therefore from bulking up. Though decreasing layer times to Snapmaker's PLA values doesn't help in our case, as tool changing and priming prevents low layer times anyway. So no need to slow down here. It would have an impact on smaller single color objects for sure. A 3D Benchy, for example, naturally benefits a lot from tweaking here. Let's take a moment and look at our first milestone. Print time slicer prediction is at 3 hours straight now. We saved 29 minutes with some baby steps in the slicer and an additional 12 minutes due to faster tool changes. Speed and acceleration didn't help much. Real print duration is now at 2 hours 40 instead of 3 hours 21. Slicer prediction is rather close to real print time and print quality is unchanged, saving around 20% of print time. Comparing a 3D Benchy at default settings and at settings now at our first milestone, it's faster and unchanged in quality as well. Some ringing on the roof is basically unchanged as well, but there is way more time saving possible. It's time for a more radical step. On the one hand, we eliminate a huge number of retracts, wiping and setups. On the other hand, we speed up the remaining retracts. I invite you all to discuss this in the comments, as this is a controversial step for sure. And here is how you can win a Snapmaker U1. Leave a comment about your take on fast printing, add your Instagram handle to the comment and follow Snapmaker on Instagram. Link is in the video description. I'll announce the winner in the next video, so subscribing and ringing the bell will help. Now back to retracts. General retract settings can be found in the slicer's printer settings per toolhead, and those can be overridden in the filament settings, specifically for different materials. Filament retracts in combination with wiping are quality insurance measures, as it aims at preventing stringing. Set hubs are print safety measures, as they can prevent collisions on bulked areas or on debris. It's a very good thing that these things are turned on by default, but in many cases you don't need those thousands of retracts and set hubs. In some, those take quite some time and might even shorten the lifespan of your set motion system. In addition, especially here for PLA, in my opinion, retract speeds and retract lengths can and should be faster as well as shorter. Especially for printers with Klipper and using Pressure Advance, the retract length can be tuned down to at least 1.0 mm for PLA. That's what we use now. Just some years ago, the rule of thumb for PLA retract speed was go as fast as possible at around 100 to 120 mm per second. That always worked nicely and saved time. The default for almost every Core XY printer today is retracts at low speeds between 30 and 50 mm per second, accelerating at 5000 mm per second squared. Check the printer tab of your printer. No matter if it's GD, Creality or Bambolab, you will most likely find roughly these values. From my time as a former speed benchy guy, I know optimizing here can save more time than expected. Though at given acceleration value and retract length, we can only reach 70.7 mm per second for retract speed. Doubling acceleration to 10K, we can reach 100 mm per second. We use the latter. You can use that simple formula to calculate. Heads up! Acceleration for extruder move must be set in firmware per toolhead as well to take effect. Alter this value in each extruder section. Also in the slicer printer settings. To test the differences of those new settings, I used the needles only from the upper part of the KSR benchmark print to compare retract quality. To my surprise, the faster and shorter retract settings, without wiping and without setups, are even a bit better in quality. There is slightly less angel hair stringing. Though still, there's a big elephant in the room to talk about later. For now, optimizing retracts, wiping and setups save us a striking 15 minutes of print time, the biggest chunk we've seen so far, though there is still unused potential around the corner. And I mean that literally. Orca Slicer allows for jerk control. In my opinion, that possibility should absolutely be used. This sets how fast the tool head moves in corners and can be set per printing feature. By default, it's just one rather low default value used for every feature of a print. Jerk control allows us to go slow where quality matters and fast where it doesn't, especially for treble moves or infill. It's important not to exaggerate here, as high values can induce rattling and therefore damage to your machine. Attention! The max value also needs to be altered in the slicer printer settings and in firmware printer.cfg. In this scenario, we save another 3 minutes. Not much, but that's also not harming your printer nor influencing print quality. Meanwhile, we saved over an hour of print time with a lot of little steps summing up, though quality remains unchanged. Up to now we have saved around 30% of print time. Though while watching we realize another part of the print that takes a lot of time. That prime tower. Printing only one colored model per build plate as we do here, the prime tower takes a lot of time in relation to overall print time. In this case, almost 1.5 hours is spent on printing the prime tower. That's a lot in relation. We won't eliminate that chunk completely, but we can optimize, as by default it's built around very safe values. Again, it has to work for a huge variety of filaments. I didn't go too deep on this, but playing around and printing I identified 3 parameters and values that make a difference. Width, prime volume and maximum wipe tower print speed. Starting with speed, here played with values while observing the resulting print time estimate. Around 200 mm per second is a sweet spot in our case. That saves 24% of print time. However, no doubt, default 90 mm per second could be more reliable in the long run. Experimenting with print volume and width has more direct effects on print quality. Too low and you'll have blobs on your prints and maybe stringing as well. 18mm width and 30mm cubed purge volume as well as positioning the tower at the rear seem to work. Hardly any blobs on the model anymore. Though, be aware, depends a lot on your filament, manufacturer, how dry is it, and so on. The stated values might not be the truth for every scenario. You might need to experiment here. In the end, I decided to go with a happy medium profile for you to download as a starting point. Kind of a balanced setup for multicolor PLA printing on Snapmaker U1. It's around 2.5 times faster or saving roughly 60% considering real print time. I tried these settings with the multicolor Deadpool as well and the result is good, while saving 7.5 hours in print time. You can try it. Printer firmware config and 3MF can be found below. Just download, upload the printer config for Klipper and load the 3MF in Snapmaker Orca Slicer. You can see the changes in printer settings, filament settings and printing settings right away as they are marked. Some are a bit higher as initially shown before, some of them are lowered, like travel and tool changing speeds. Briefly testing the maximum possible speeds the U1 can go at high acceleration, I figured that 800 mm per second at 25k acceleration might work for tool changing and travel moves, but it's too close to the limits of the XY motors. The absolute limit seems to be somewhere between 800 and 900 mm per second at 45-degree moves, so there wouldn't be much of a safety margin. If you like, try and test JMP's TMC optimized settings for PAX firmware to make travel moves and tool changes even a bit faster. Now, more speed, higher acceleration, faster cornering, tweaking some of the little things, faster retracts and getting rid of setups as well as speeding up the prime tower printing. All of that to save around 60% of print time. Is that worth it? On the one hand, yes, it makes that difference of a print finishing the same day or if it still has to print overnight. Plus, tweaking and pushing limits is fun, at least I had a lot, as you get direct results of your doings. Additionally, you're kind of invited by Snapmaker's open source U1 and open source Orca Slicer to do so. On the other hand, there must be a caveat. I can feel the itching in your fingers to write exactly that comment, wear and tear. Yes, we just don't know if speeding up like this will cause higher wear and tear for the printer. Some stress increases for sure. Higher acceleration, faster cornering, increased tool changing speeds. I can understand many of my viewers stating, "Nah, not for me, I can wait for a print." Fair enough, there's nothing wrong about using Snapmaker's defaults for U1. They are tested and they work. Huge thanks to Snapmaker for sponsoring this video and for being a consumer-friendly company. If you are thinking about getting a Snapmaker U1, consider using my affiliate link below to support my work. And yes, I'm on Patreon too. See ya in the next one, servus and bye bye. Thank you, Shulo!